Alright, this is going to be a video on algebraic equations. We're starting to get into equations, and we learned that an equation always has to have an equal sign. That's what an equation is. And when we have an equation, we compare an amount on one side of the equation, and we say it's equivalent or equal to the amount on this side of an equation. So we could say that if we have 4 pounds on this side, it's equivalent to 4 pounds on this side. They have to be balanced. Just like our pan balance, we have an equal amount of weight. That's the same thing with equations. And the best way that I can show you on how to start equations is compare them to our function tables. I'm going to take this function table and I'm going to graph it, or I'm going to set it into a number sentence so we can see it as an equation. But first of all, we have to remember how we compared our set of data. Let's look at the x column. I have the numbers 1, 2, 3, and 4 that could represent x because they're all in the x column. Then I have the numbers 2, 4, 6, and 8 that could represent y because they're all in the y column. We have to compare these two columns in order to do our algebraic equation. So the first thing I'm going to ask myself is, how does an x turn into a y? Or how does a 1 turn into a 2? I know there's two options for this. I know that a 1 is getting bigger to turn into a 2, so I'm either adding or I'm multiplying. I know that 1 plus 1 equals 2, but I also know that 1 times 2 equals 2. So I know that one of these two could be my options for my rule from x to y. So let's go down to 2. I know that 2 plus 2 equals 4, but I also know that 2 times 2 equals 4. So far I know that times 2 is the pattern that I've seen so far. I know that 3 plus 3 equals 6, or 3 times 2 equals 6. Well, I have times 2 here, here, and here. I think it's safe to assume that 4 times 2 is 8, and that could be my pattern. So when I'm going from x to y, I am timesing or multiplying by 2. However, if I'm going from y to x, I'm doing the inverse operation, or the opposite of multiplication, which is division. And I know that I'm dividing by 2. I know that 2 divided by 2 equals 1. 4 divided by 2 equals 2. 6 divided by 2 equals 3. And 8 divided by 2 equals 4. So I'm just looking at these numbers backwards in kind of a sense. Alright, the next thing we're going to do is we're going to get started with the equations. So make sure that you listen very carefully, because this is something new, but it's what you're going to continue to do all the way through middle school until you get to geometry. This is all algebra, and this is the very beginning of it. So what I'm going to do is I'm going to tell you, when you have an equation and you have variables, you're going to compare the two variables. And in this case, I have two variables, or two letters. I have an x and a y. And I'm going to compare, and I'm going to say x is equal to y. And if I were to plug in x and y for the numbers that I have for x and the numbers I have for y, I could prove that that is not true. Let's look at the first number I have for x. I have a 1, so I'm going to erase that x and I'm going to put 1. And then let's look at the first number that I have for y. It's a 2. I'm going to erase that y and I'm going to plug in 2. I know that 1 does not equal 2. That doesn't even make sense. So that cannot be our equation. X equals y cannot be our option. So instead, I am going to go back and I am going to write x equals y. And I'm going to leave this x alone. I want this amount on this equation to be all by itself. I want to have one variable all by itself on our equation, or even our teeter-totter, or our pan balance. I want this x to stay alone. And then I'm going to look at y, and I'm going to ask myself, what can I do to this y to turn it into the same number that is represented in x? So let's go back to our list of numbers and let's start plugging them in. Once again, let's go back to our first value for x, which is 1, and our first value for y, which is 2. And let's take this x and let's turn it into a 1, because that's what's here in our x column. 1, it's the first number. So I'll just go right below it so we can do this in steps. I'm going to take this x and I'm going to turn it into 1. And I don't know that 1 is equal to y. Well, what did we say our y number could be? Well, it's the first one here that corresponds with 1. If we move over, it is 2. I know that 1 is not equal to 2, but I'm plugging in the numbers and I'm just dropping them down. So how could I get this 2 to turn into a 1? And I know by my rule, my inverse operation, if I go from y to x, I'm going to divide by 2. So I know that 1 equals 2 divided by 2. Is that a true statement? Well, if I bring this down, I know that 2 divided by 2 equals 1. And then if I just drop my 1, is 1 equal to 1? Yes, it is. So I could go back and erase this. Okay. Oh, I'm sorry. I know. If you can see all this, 1 is equal to 1. I'm going to go ahead and erase this. And I know that my rule is now x is equal to y divided by 2. And just to double check, I want to plug in numbers to make sure that this is true. Once again, I want to leave one of the variables by itself. I want to leave x by itself. And I want to see what I can do to y to turn it into an x so that they're balanced. And I know that x equals y divided by 2. Let's see if that's true again. Let's take another number for x. Let's take 2. So I'm going to take my x, I'm going to drop it down and turn it into a 2. I'm going to drop my equivalent or equal sign, and I'm going to take my y, drop it down, and turn it into my value here, which is 4. Well, I know that 2 is not equal to 4. X is not equal to y. But if I add on the divided by 2, which follows our rule, y to x is divided by 2, I know that 2 equals 4 divided by 2. Why? Because I know that 4 divided by 2 has to be 2. And I could drop my 2 down. I know that 2 is equal to 2. So therefore, my rule for this first algebraic equation is x equals y divided by 2.